Saima?
Yes. Yes, Rebecca.
Please. Yes, please. Good morning.
Good morning.
Please, I can't hear you well. Oh, please. The information you have given, can you give it out again for me to hear?
Which center are you, Rebecca?
Zenith.
And then the information is not for you.
Yo, thank you. Yeah.
Hey, Emma.
Yes, madam.
Emma, please, I paid for fees, but I've not gotten my index number yet. How will I do the registration today now?
Please, which center are you?
Sinyani.
So you just have
Yesterday,
your
I
name.
remember that
When you
I
finish
have
the
added my name
registration,
already.
then that is it. I will include it. When you finish your
But
registration today,
I'm not having the index number to do the registration.
have you done the registration?
No, please. I'm not having the index number yet. How do I do the registration?
And you finish your payment, the fee.
Yes, please.
And then you need to contact the
Yes,
center.
yes. I contacted yesterday, the message that came yesterday, the number I called yesterday, but I couldn't pick. I sent SMS, but I've not received any message yet.
And today they will be doing the registration. They will open the portal this morning. So when you finish the registration, I believe you will get it. I also went through similar ordeal.
Can I do the registration without the index number?
Use your reference number. For the reference number during the application, we were all given reference numbers.
Yes, please.
So use the reference number because some of the index numbers you need to go online and then you'll be able to get it from online. There is a place that it will ask you of your name, your course you are doing, and then your reference number, and then it will give you the index number.
Okay.
And some too, you have to contact them yourself.
Okay. Thank you.
Mohammed, background noise. Mohammed, mute your mic if you are not talking.
I'm going to talk, but you are not. My hand is up.
Okay, talk.
Please, we were told to print our admission letters with the colored background, but I went to do that and I couldn't access it.
You were told to print your admission letters with the colored background.
Yes.
Yes. And you said?
I went to do that and I was not able to get access.
Hello.
We'll do that later. Yes, sir. Yes, sir.
I hope it's clear now.
It's clear now, loud and clear.
Okay, thank you.
Okay.
All right, so please, let's just start. We've wasted, I think, almost 1 hour. So let's start.
Hello, sir.
Yes, I'm trying to share my screen.
Okay. I thought you are cut off again.
Oh no, I'm working on sharing the screen.
Okay, sir.
Can you all see my screen?
Yes, please.
Okay.
Yes, sir.
Okay.
Keep quiet, I'm in class.
So we are going to continue with where we ended last week. So now we are going to start from how electricity gets to our various homes. This was what I was talking on before my network started going back and forth. So we are looking at how electricity gets to our various homes. Okay. Now, for electricity to get to our various homes, we have 3 stages or 3 processes by which electricity goes through before it gets to our various homes. The first stage electricity goes through before it gets to our home is generation. Okay. Generation. This is where the power or the electric power is generated from sources of primary energy, such as the hydropower. When we talk about hydropower, please, do you know what hydropower is? Hello?
Yes, sir. Yes, sir.
Hydropower. What,
Yes, sir.
what does it mean?
Water. The electricity that we get through water.
Okay. Okay, that is good. That's good. So primary sources such as the hydropower, the fossil fuel, that is the thermal energy. We also talk about a renewable source. So we have some of the electricity that we get from the hydro, that is from the water. So a typical example is the Akosombo Dam. Okay. So we have a point at which the power is generated. A point at which the power is generated, and we call this point generation or generating station. Generating station, and this is done by using huge generators. So those of you who have been to, and it says that in Ghana, the 2 main generation stations are the Volta River Authority, which is a hydropower, and then we have the Bui Power Authority, that is a thermal energy. So electricity is generated using hydro as well as thermal power and fueled by crude oil, natural gas, neutral gas, and then diesel. So when you go to the Akosombo Dam, I don't know how many of you have been to that place before, but you realize that there is rotation of turbines against each other. You know what the turbines are, right? Hello?
Sir.
Please, can you hear me? Or I'm going too fast.
It's okay. Mommy, I'm in class. Stop talking.
It's okay.
Do you know what turbines are?
Yes, sir.
What are turbines?
We can only I can only describe it, but I can't define it.
Okay, so describe it and let's see.
When you get to the Akusumu Dam, then there are those big cylindrical passage where water passes.
Okay. So when the water is passing, what happens?
Hello, sir.
Yes.
Please, I think when the water is passing, those turbines, they turn. They turn the rate of the water that is flowing, and in the process of turning, they end up to generate what? The current from the water. They turn against each other.
Okay. So they spin or turn against each other, right? They will be spinning or turning against each other. Now, this will send us back to how we said that heat energy is generated, or how we said energy is generated. Remember that we were saying that for heat energy to be generated, there should be the movement of electrons or molecules, okay, or particles. There should be a movement. So when these turbines are spinning against each other, there is what you call the generation of electricity. So now when this one is generated, or after this has been generated, it moves to a point which we call the transmission point. Okay. After it has been generated at the generation station, it moves to a point that we call the transmission point. So the current that was generated will be sent through a transformer to increase the voltage to push the power to distant locations. So you can imagine how electricity will travel from all the way from Akosombo to Tamale or Boga. How this electricity power will travel all the way from Akosombo to Boga or other places. In fact, I even hear that we give Nigeria some amount of electricity. So let's ask ourselves, how is this electricity able to travel from the point at which it has been generated all the way to these distant places? What is being done is that after the power has been generated, there is a process that the power goes through. So the power is sent to the transmission point where the voltage is increased. So when the voltage is increased, it is able to move this current that has been generated, or this power that has been generated, to distant locations. And then when it gets to this distant location, so it says that the electrical changes then goes through high voltage transmission line that stretch across the country. This is normally done by GridCo, that is the Ghana Grid Company. The Ghana Grid Company, they are responsible for the transmission through the entire country. So it says that we have 161 kilovolts are transmitted through bulk supply points. So when you talk about the bulk supply point, you agree with me that it is talking about sending the power in huge amounts. Please, is that okay?
Yes, boss.
Yes, please.
Yeah. So it's sending the power in huge amounts. Now, when it gets from there, when it's being transmitted, after it has been transmitted, it will get to a point. And when it gets to that point, because the voltage is very high, we are supposed to bring the voltage down. The voltage is supposed to be brought down so that now it's being sent to our various homes for us to be able to use. So the point at which the voltage is brought down and then being shared to us in our homes is known as the distribution point. Okay? The point at which the power is brought down again to a normal level and is being shared with us in our various homes to use is known as the distribution point. So at the distribution stage or point, this is where the power is being stepped down. So here you can see two different things we are talking about here. We are saying that first we have a transformer that steps up the current, okay? We have a transformer that steps up the current during the transmission. So it steps it up so that the power can travel to distance locations or far places.
Boss,
Yes.
you went off for about 10-15 seconds. So if you can go by a little, yes.
And so
Yes,
please,
please. We can't see
you
your
take your
slide.
time a little.
You can see my slide.
Yes, please.
Yes, the slides too are off.
Hey.
So please, you
Yeah.
take your time too.
Okay. But is the slide showing now?
No, the slide,
No, please.
the only one that's slide. How electricity get to our home, that's the only one on it. It's not going or it's not coming down.
Yeah, I took it back. Okay. Let me share it again.
Yes, please.
Is it showing now?
Yes, sir.
Yes.
Yes, sir.
Okay. So I was saying that how electricity gets to our homes. The electricity goes through three main stages before it gets to our home. Okay. It goes through three main stages before it gets to our home. Now, the first stage is the generation stage, where the power is produced or generated. And we said that we have 2 points in Ghana here, or 2 places in Ghana here where power is generated. So we spoke about the Volta River Authority, which is the VRA, that is a hydropower. And then we have the Bui Power Authority, that is the thermal energy. And from there, we are saying that this energy or this electricity is generated using a hydro as well as a thermal power. And all these are being fueled by using crude oil or natural gas and diesel. So the plants that are being used to generate this electricity is being fueled by what? Crude oil or gases or diesel. That is what they use to fuel the plant to be able to generate the electricity. And then I asked a question. Somebody was like, when you go to Akosombo, you see these big turbines. We call them turbines. Okay, she sees them as cylindrical objects. And you will see that as more as the water flow through it, the water causes them to spin. Okay,
Rose,
or the spin.
Rose,
Let me use the
mute
spin.
your
So
mic. Rose. Oh.
So as they are spinning, they rub against each other, and then this is where the power is generated. Then I'm saying that after generation, we have what you call transmission. So the power that is being generated from the generating point is now going to be what? Transformed or transmitted to different places. Now we are generating the power at a source, but we cannot use all the power at the point at which it's generated. We are supposed to distribute it across the country. So what do? There should be means by which this power that has been generated at this point can be pushed to various areas in the country. So how can we do that? We have to what? Step it up. We have to step it up or increase the voltage. Now, in increasing the voltage, we have what we call the what? The transformers, which are being used to increase the voltage. So we have the step up transformer, which is used to what? To step up the current or to increase the amount of energy that has been produced. From transmission, then you go to distribution, where now the current has gotten to a bulk supply point in our jurisdiction or in our local area. Then now at that point, the power is supposed to be stepped down. The power is supposed to be stepped down so that the voltage will come down to the level at which our devices or gadgets can be able to use it. So we are saying that the power that has been generated from the source is being transmitted from the source to various areas. And then when it gets to the bulk supply point, it is being stepped down and then now distributed to our various homes. I hope this one is clear now.
Yes, sir.
Yes, sir.
Or I've still gone too fast.
Sir, it's normal.
Okay. So during the distribution stage, so what I was talking about first before you said I should go back, I'm saying that you are seeing two different kind of transformers in play here. So during transmission, we have the step up transformer. Step up transformer. Is that okay?
Yes, please.
And then during distribution, you have the step down transformer. Step down. So the step up increases the voltage of the current, the voltage that has been produced, so that it can travel to distant places. But then the step down transformer will step it down. It will bring it down to the level at which our devices in the house can be able to contain or can be able to manage. Is that okay?
Yes, sir.
Yes, sir.
Yes, sir.
So the voltage that has been produced, which we said that it is 161 kilovolts, 161 kilovolts, will now be stepped down to what? 220 or 240 volts. Can you see this one? Can you see what I'm showing on my screen now?
Yes, sir.
So this is the amount of current that is transmitted through the bulk supply point. I've mentioned this one already, right? The bulk supply point.
Yes,
so this
sir.
amount, 161 kilovolts, is transmitted through the bulk supply point. Now, when it gets to the supply point, then now there will be a step down to what? 220 to 240 volts. And this is the level at which our devices in the house can be able to what? To manage or to control. Now, some of you have what we call stabilizers in our various homes. So we call some step down stabilizer, and then we call some step up stabilizer. Or nobody have a stabilizer in the house?
Sir,
we have them.
we do.
What does the stabilizer do for you? What is the purpose of the stabilizer?
When the voltage goes up,
Please raise your hand first and let you be called.
it stables it.
Yes, Adam.
So sorry, the stabilizer is reduces the current to the voltage the electrical appliance can take.
It reduces it.
Yes, it manages it to that stage. There are certain appliances that it takes high current and others too, unless it's low.
Okay. Winnie.
Say it regulates amount of voltage for an appliance to be used.
Okay, it regulates the amount of voltage for an appliance to use. Alice.
It controls the flow of power within a circuit so that it can regulate the amount that will get into the appliance. Since every appliance has amount of voltage that is needed to operate it, so it controls the flow of the voltage.
Okay, Mr. Emma.
Sir, I want to ask a little question.
Okay.
Do we have Felicity? You are disturbing us. Please, I want to ask, do we have a step down and then we have stabilizer itself, or is the same thing? The reason why I'm asking this is the one we use our homes right now is to regulate or maintain the power that is stable for the appliances. But we also have another one that also step down the power to appliances that uses 110 volts. That is appliances from the US. So I don't know, is it the same thing or there is a difference?
So you see, what happens is that we have two forms of transformers. Transformer is a different thing. Now we are talking about stabilizers, okay? As the word goes, stabilizer. What the role it plays is that it has to stabilize the current that is coming to your home. You get it? For you to be able to use. Now, what I'm saying is that in some of these stabilizers, we have transformers in there. Okay. Normally the stabilizers actually brings down, they neutralize the power. That's their main function. They have to neutralize the power so that it gets to the level that your appliance needs. So for them, what they do is that when the power is low, when the current that is coming in is low, then they will have to step it up. When the current that is coming is very high, then they will have to step it down. You understand?
Yes, boss.
So that is what happens. But then within those stabilizers, there are transformers that are actually playing that role.
So the one that we use to reduce the power to gadgets that are 110 from the US, that one too is stabilizer.
Yeah, so it will be a step down stabilizer.
Okay, so there is a difference, a step down stabilizer and then the normal stabilizer that we use.
So we have stabilizers that, what I want you to understand is that we may have a stabilizer that will play both step up and step down role, depending on where you are using it. Okay.
Oh,
We have
okay.
a stabilizer that can play a step up and then a step down role. We also have a stabilizer that its role will solely be maybe stepping up the current. And this will be used by people who are normally suffers having low voltage current in their areas.
Okay.
They will have the step down, which will also be good for those who will be going through excessive or higher voltage current in their areas.
Okay. Okay.
You get it? Aha.
Yes.
So that is it.
Okay, thank you.
You're welcome.
Sir, you are off.
I'm not off. I'm doing something.
Oh, okay. Oh, okay.
Sir, please, 2 hands are up.
Okay. Sorry. Let me mention their names so that they can also contribute.
Abigail and Alice.
Okay, so Abigail, go first, then Alice will follow.
Sir, I
Yes.
just want to find out why the gadget from the States need a step down.
Yes, who would answer this question for us?
Is what I just said. Their voltage is 110. And we are using 240, 220 to 240. I remember I caused trouble with these step down stabilizers. There was a machine that was brought from the US for me to put it on, and I forgot it, and I just put it on from the main power, and then it just get blown. I forgot to use the step down. So it's something that is still with me during, it's about 20 years now, but I still remember it. So it's just there for you to bring the voltage down to the level of the US gadgets. So until you make changes in the gadgets to take up the 220 to 240 volts, you cannot switch it on directly using our voltage in Ghana. If not, you just destroy the machines. Thank you.
Thank you.
All right. The next question.
Alice.
Sir, please, I already spoke. Thank you. I'm going to put down my hand.
Okay.
Then Abigail. Boss, we can continue.
Yes, Winnie, you want to ask a question?
Yes, it's great, but I'm using someone's logging in. So I want to ask, does it mean that every appliances and its voltage? What if in a house you have different appliances with different voltage use? For example, just as Seima said that the US appliances uses 110. What are you going to do?
Yes, what are you going to do? Let's help her. She wants to know what to do. Yes, Adum Eunice.
But I think you said you told us some of the stabilizers they are more step down and then step up. So I think will help you
Akusia, please. Akusia.
Yes, I didn't hear
I
what
don't.
you said. Though.
I don't. Please continue.
So I said, as you said, like there are certain stabilizers that will step up and step down. So if you think the appliance in your home needs those step up and step down, you can't buy just step down stabilizer for this one and then step down for this one. I think getting both step up and step down will help get all the household appliances in reducing the vote. If it needs to step up, it will step up. If it needs to step down too, then it will step down for you so that you don't destroy any electrical appliance. Thank you.
Yes, Mr. Emma.
And then again, these steps downs and ups comes in voltage. So if you have 2 or 3 gadgets that needs to be stepped down, then you purchase your step down stabilizer according to its capacity, so that you'll be able to switch maybe 3 gadgets on using the same stabilizer coming from the same source. But buying about 3 or 4 or 5 step down for different gadgets at different locations, that one have to depend on your pocket. Thank you.
Okay, so let me add up to your question, to the answer. So, what's the name? Madam Winnie. What happens is that these stabilizers, they have range, okay? The range at which they can work. So I was just searching for some to see if I'll get a good image to share with you, but then it's not coming clear. But some will be within the power range. So you see that, as Mr. Ima is saying, from 110 or 100 or 140 up to 240. So it is the range. You get it? It is a range. So if you have this kind of stabilizer, and then now you plug the stabilizer to the main source of the power, then after that, some of them have a lot of plugs on them. Some do not have a lot. So what you will do is that now you use an extension cord to tap the current from the stabilizer. So now the stabilizer, the power is not coming to your device directly from the switch or from the main source, but it is going to go through the stabilizer for it to be stabilized. So far as the range is 120 to 110 to 120 or 110 to 140, whatsoever range within which your device or appliance is, this transformer or this stabilizer will still be able to help the device to be able to withstand the amount of current that is coming, because the stabilizer is going to neutralize the amount of voltage so that the power and the device can be able to use it. Is that okay?
Yes, sir.
All right. So it says that here the electrical power, which is now at a lower voltage, is distributed to individual homes. This is done by the state-owned electricity company of Ghana, the people who have chopped the plenty money and then they are going to jail them.
Of course.
At this point, the electricity travels through wires inside the walls, okay, to the outlets, and then they switch all over the house. So after the power has come from the generation point to the transmission point, it's transmitted to your houses, and then it's transmitted to the bulk supply point. From the bulk supply point, it is being stepped down and then now sent to your homes. Then you also tap it, and then you distribute it through the wires in your home. So you have points at which you close your switch or you close your circuit, and point at which you open the circuit. So the switch and then the sockets in the house are what help us to now put on our electricity or use the electricity after it has been distributed through the wires, and then in the wires within the walls in the house, so that we can use it and use it well. So say at this point, the electricity travels through wires inside the walls to the outlets and switches all over the house. So let's look at this diagram. Can you see the diagram?
Yes, sir.
Yes, sir.
So now you can see the production center. After the power has been generated from here, okay? After the power has been generated from here, this power now is what? Stepped up with the transformer. So this place, the power from the generator station is transferred to a transformer, and this transformer will step it up. After this transformer set it up, you realize that it will be passed through this poles. This one you call them high tension, right?
Yes, sir.
Yes, sir.
So it should tell you that the voltage that is going through them is very high. That's why you are calling them high tension. Then now you come through the high tension where you see that there is another transformer here, which is going to step it down. Now, if it steps it down, then it takes it through the smaller light poles and then wires we see in our communities. Then now the home can tap from that to the house, and then we also use it. Is that okay? So the same example here, we have the generation plant, we have the step-up transformer, we have the transmission from the step-up transformer to the step-down transformer, and then it steps it down, it comes to the wires, and then we tap into our various homes and we use it. I hope that is okay now.
Yes, sir.
Yes, please.
Please, I have a question.
Okay, go ahead.
My question is, there is this notion that some people have that if you have a stabilizer in the house, even if the voltage is low in the community, or maybe there's low power shedding in the community, you, the one using the stabilizer, will able to attract or absorb a lot of current. How true is this?
How true is this? Please, do anybody have any contribution or anything to say about it before I come in? How true is this?
Please let her come again. I don't get it.
What
Please,
you
my
mean to say is that, okay, go ahead.
Please, my question is, some people have the notion that if you have stabilizer in your house, and even if the area, your community, there is low power shedding, you, the one having the stabilizer, you will be able to absorb a lot of voltage or current. Please, I want to be sure, how true is it?
Yes, please, let's share our views if you have anything to say about that.
Hello. Yeah, with my experience, when the power in the area is a little low, maybe if you plug some appliances like microwave directly, it wouldn't work. But when you plug it using the stabilizer, it works. That's what I've experienced in my area.
Yes, anyone else? Mohammed.
Sir, I would say that with the power supply, because it's a stabilizer, usually the current flow to the stabilizer is not all that lost when there is power outage within your community. Therefore, you still have some to use before you regain your current back.
Okay. Mr. Ima, no, Mr. Ima's hand is not up. Is it Mabina? Hey, this Mabina, the spelling is Mabina, talk.
Okay, sir. The explanation coming. Can you say that the stabilizer says a power bank? The
I didn't
question
get.
that someone asked that said in her home when the voltage is low and then cannot power the microwave, when she uses the stabilizer, it's able to work. So I want to ask that, does that mean that the step down serves as power bank?
We are not done answering the question and you are bringing another question. Okay, Sandra.
Okay.
Yes, sir.
Please, can I come in?
Okay, let's take Sandra first, then you come in. Her hand has been absent.
Oh, okay. I wanted to ask a different question.
Hey, okay, don't worry. Then those who want to answer the question come first. Mr. Emmanuel.
Okay. So what I want to say is, I don't think it is true with that notion. Even using of UPS that we use for computers, they absorbed or they saved power for you to use the computer for some time when the power is off. So when you are using a stabilizer, it is not, to my knowledge, it is not true that you will be consuming or you'll be preserving power as against your neighbor using. No, the stabilizer is only there for you to stabilize the power flow that is coming into your house so that it will not destroy your gadgets. Low currents normally destroys gadgets. High currents also destroy gadgets. At times you'll be using your fan, and then the same number that you have put it on, it goes up for some time, then you see the fan coming down as if you have reduced the number, but it is still the same number. So you could see that there is a fluctuation of the current, and that should alert you that you should get a stabilizer for your gadgets that you are using. So I don't think it is true, to my knowledge. Thank you.
Okay, that is very good. Mavis, what do you have to say? So that I come in after you, then we'll continue.
Okay, so I think the question or the notion they have is somehow true, because in your submission explaining what stabilizers do, at some point you said that they are able to regulate power such that sometimes when power is low, they are able to step it up. And when the power is too high, they are able to step it down. That means when power is low in the community, the one who has stabilizer at home, the stabilizer can step it up a bit for the person to have power at home for a while, maybe. To my understanding, that is how I get it. I don't know whether I'm right.
Okay, so let me just come in and then so that we'll go towards more. Okay, the whole thing is that, please, the stabilizer is not going to be increasing your voltage for you when there is low power shielding or something. No, what the stabilizer is doing for you rather is that at that point it will rather prevent your device from being destroyed by that power, low power or low current. So it is not going to step it up for you to be able to be using it while some people are not getting it to use. But instead, you know, sometimes you leave your gadgets like the fridge and all those things on, and then when the light goes off, you have to go and then put it off. When it comes, you have to put it on. But sometimes you are not in the house and then this light goes on and off and those things. So the stabilizer is going to make sure that the power that is coming does not go directly to the device to damage or destroy the device for you. So it will neutralize the power, but to increase it when it is low for you to use whilst other people are not. No, it's not true. It doesn't do that.
Okay.
Is that okay?
Okay, sir.
The person who asked the question, are you okay? The one who asked the question, are you okay? Am I live or I'm out?
You are alive.
Yeah, you're alive.
Okay. So where is the person who asked the question, or the person went off? All right, Mabna, your hand is still up. Abner, your hand is still up.
Yes. Yes, sir. Sir, please, the second diagram,
Okay.
the power grid framework. You
Uh,
see the I saw that industrial customers and then residential. You see, with the residential, we pick our power from the light pole, right? I don't know if I'm right.
Sure.
Okay, so meaning that the industrial customers, they don't take it from the light pole, but they take it from the transformer. I'm a bit confused here.
No, I'm also not getting what you are talking about.
So from the diagram, you see generating plant. I'm talking about the second one, not the first one. You see there were two diagrams. I'm talking about the second one.
Which
second
one?
That generate
this.
Yes, the
this
second one.
This one.
So what I have here is types of transformers. So I don't know whether that's what you're talking about.
Is it this one?
Is your screen is off?
My screen is off.
Yes, they're sharing.
Again. Oh, why is the internet behaving like that today?
So it's everywhere. Not your end again.
Is it this one?
No, sir.
Please go up a little bit. One of the slide up.
Is it this one?
Your screen is not changing. No, you are still. Is now off.
What is? It's off.
Yes.
Oh, what is happening?
The screen is on, but it's not changing. It's off now.
Hello.
Yes, I think this one.
Okay.
Not this one, the other one.
The next one, the one at the middle. This one.
This one.
Okay.
Yeah. So you see, from the generating point, it went to a step down transformer, then to the what we call high tension.
From the generation point, it didn't go to step down, it went to step up.
Okay, yes, sorry. Step up. Then it went to the high tension that we call them. Then another transformer. That is the step down transformer. So looking at the industrial customers and then the residential customers, you could see that the residential customers are tapping from light poles. And I want to know whether both industrial customers and then the residential customers tap from the same source, that is the light pole, or the diagram. I think they will see.
So,
can I come in?
Yes, please come in.
From what she's saying, seeing the pole in between the transformer and then the residential customers. That's why she's asking that question. But the thing is, they are all picking up from the same source, which is the substation, the step down transformer substation, the low one. But because it is industrial, the way they do their connection, they do the connection straight to the transformer. but it doesn't mean that they don't use the pole. Some of them use it, but because they don't distribute, their own goes straight to the industry. That's why you don't see another pole giving it to, because they don't use what we use. They don't use the normal, because if you could understand this, the light that we normally used, these Nika people, when they connect with the same line with us, these mill that they grind corn and the rest, they distract or they disrupt our line, the main line from the pole. So at times they get it straight from the transformer, not from the distributing on the pole, so that it will not affect the residential customers. Have you some of us, have you experienced that? That if we are using the same line with these industrial people or the Nika people now, then our lights at times don't stand on.
Yes,
It gets
it's very
distracted.
true. Yeah.
Yes. So that is the reason why. Thank you.
Please, are you okay now?
Yes, sir. Thank you.
So even from the, if you can see from the transformer, okay, we have another wires that are connecting to the industry. Just look at it. There are wires. Before, there are wires that are also connecting to the home. So now, when you check in your community, if you are working, I'm giving you an assignment or an activity to do. If you are working in your community, those that are close to the road, you see that you have two different poles. You have the pole, the longer ones with these 4 wires on it. You see, which you see those ones are going to be traveling far, and then we have the ones that have these smaller ones on it, which you can tap. So anytime you want to tap light, electricity to your home, they don't go to the main wire, the big ones, they come to the smaller ones to tap from there for you. Do you see what I'm talking about?
Yes, that is.
Hello?
Yes, sir, that is very true.
Yes, sir. We are listening.
Now, let me give you another example. Those of you who have lived in a family house before, when there is a program in the house and they are coming to use electricity, do you see that they don't fix the sound system they don't plug the sound system from street or from any socket in the house, but instead they will go and tap it directly from the meter?
Yes, that is also true.
So that should tell you that at every point in time, the voltage that is flowing is very high. So unless it is coming to your devices, so the question you were asking, they still cannot go directly to the transformer to tap from the transformer. They still tap from wires. But we have different voltage that are going through different wires at a particular time. So those in the DCG, they know what power is supposed to be sent to which people, so they do it accordingly. That's why if you want to tap electricity to your home, you have to consult them for them to come and do it for you. You don't have to do it yourself, because if you don't take time, you will burn the whole town. So they would come and do it for you, and they know which power or which voltage is supposed to be sent to which point at a time. But all of them still will tap from the wires. Okay. I hope I've made myself clear.
Yes, please.
Okay. All right, we've spoken about this already, so we can move on. What step down and then step up transformers are. Now let's look at Ohm's law. So far as we are getting close to Ohm's law, you should know that we are getting close to calculation, right?
Yes, sir.
All right. So
Sir,
what is
please.
Ohm's law? Yes.
Sir, please, I've put a sample of the stabilizer and then the step down on the platform, so we can have a look at it.
On your WhatsApp platform, right?
Yes, please.
Okay, so please, those of us who are confused, Just try and then check it out and see. Okay, please, can you see it? I'm seeing it. So you see this is the small type of the transformer. And then we have the stabilizer to here. That is a typical example of it. Now the transformers, we have big transformers in our community, especially by the roadside, and they will make a fence around it. Then they'll say that don't go close to it because it is dangerous.
Danger, yeah, danger.
Okay. All right. So what is Ohm's law? From our class 1 or basic school knowledge, we say Ohm's law states that the potential difference across a conductor is directly proportional to the current flowing through it at a constant temperature and what? Pressure. Do you remember that definition? Hello?
Yes, boss.
You remember that definition, right?
Yeah.
Yes, boss.
Achewon. But let me make idea also okay. So it is here. So you are saying that Ohm's law says that the voltage across a conductor is directly proportional to the current flowing through it, provided all physical conditions and temperature remains constant. Just as I said, it's different. It's just the reframing of the word. So mathematically, what it's telling us is that V, which is the voltage, is going to be equal to current plus what? Resistance. V, which is the voltage, is going to be directly proportional. That is equal to current and voltage. So the same equation can be written in order to calculate the current. So if you want to, so the main equation is this one, okay? That if you want to know the voltage, voltage is equal to current times resistance. Now, if you want to know the current, they will do what you call change of subjects. You know, you remember, right? So we have V is equal to IR. You want to calculate for R. So what do? You divide both sides by R, and then it will be V over R is equal to I. Like you see here. If you want to calculate for resistance too, it becomes like this. Can you see it? I hope you are seeing all the things I'm doing.
Yes,
No,
boss.
please. Yes, sir.
Hey, who says no? Who said no?
Please, you were saying something. If you are to do the change of subject, that place I'm confused, please.
Don't be confused. This is what we are saying, that the Ohm's law says that the voltage across a conductor is directly proportional to the current flowing through it at a constant temperature and pressure. And we are giving it mathematically to be V equal to R plus R times R, I times R. So if you want to know the voltage that goes through a conductor at a time, you calculate it by multiplying the current times resistance. Now, the same way, if you are being given voltage and you are given resistance and you want to know the current, you do that by dividing the voltage by resistance and you get the current, which you have the formula here. The same way, if you have voltage and then current and you want to know the resistance, you also divide the voltage over current to give you the resistance. So that one is also given by the formula or the equation here. Do you understand it now?
Yes, please.
So these ones are mathematical operations. It's the same thing you have here. All right, now let's move on to look at what a circuit is. we'll be doing some few calculations down there. So when I'm done with this, then I'll give it to you. So a circuit is a path in which electrons from a voltage or a current flow. We've said this earlier on. An electrical circuit is a complete path through which electric current travels. The point where the electrons enter an electrical circuit is known as, or is called, the source. So where the power is entering into the circuit is known as the source. That is why in your various homes you have something called a main switch. Is that okay? You have the main switch. So the main switch, if you put on the main switch, it means that the current is going to flow from the source into the circuit. If you keep off the main switch, it means that you have prevented the current from coming from the main source into the circuit. Then the point where the electrons leave an electric circuit is called the return or earth ground. Is that okay? So in the electric circuit, we have series of wires or set of wires that are used in the electric circuit, and all have their roles and functions they play in that circuit at a particular time. So it says that an electric circuit consists of a collection of wires connected with electric components in such an arrangement that allows the flow of current within them. So these are some of the components of an electric circuit. We have the wire, we have the battery, we have the bulb, we have the resistor, and then we have the switch. Are you okay?
Yes, sir.
Yes, sir.
All right. So this is a cell. This is a cell. The battery is known as a cell. So it converts chemical energy into electrical energy by chemical reaction. Usually the chemicals are kept inside the cell. It is used in a circuit to power other components. So the battery, you realize that if you should break it open, you see some juicy something in it. I say in the battery. Normally, it is not juicy until the battery is getting spot. When the battery is not spot and you break it, you see that it is hard, but it's chemicals that are there. And these chemicals are used to power the circuit. So we have the switch or the key. It is used to open or close the circuit. So your switch in the house, when you keep it on, it means you have closed the circuit. When you keep it on, it means you have closed the circuit. If you keep it off, it means that you have opened the circuit. Is that okay?
Yes, sir.
When the switch is turned on, you have closed the circuit. When the switch is turned off, you have opened the circuit. Okay. And we have the fuse. What is the role of the fuse? The fuse is a small piece of thin wire within the circuit, which blows off to prevent the whole circuit from damage when there is excessive current. So when the current is more than the circuit can bear, the fuse will heat up and then what? Blow. If it blows off, it cuts short or it opens the circuit and prevents current from flowing to other components of the circuit. And so for that matter, it prevents the place from burning, or it prevents the whole circuit from damaging. Then we have the wire. The wire is the pathway through which the current travels from one side or one point to the other. I hope I'm not going fast.
You are.
Oh, but these things are simple things we have been hearing always, right?
Hello.
Hello.
Yes.
Sir.
Yes.
Yeah, the network is not good. After stabilizer, I'm now hearing you again.
Hey, eh, you
Hey,
saw some. You see the way I've even
Yeah.
screamed. You see the way I've screamed. Brimpon, what is the problem?
I don't know.
Before, if that is the issue, then it means you will be drawing us backwards.
Yeah, so when we are done,
Yeah,
you contact some of
Then
your
when
colleagues
we are
to know
done,
more.
then we explain that part to you.
yeah.
Please, are we okay?
But say you are moving fast. Yes.
Oh, this one's Mr.
Yes,
Ima.
so boss,
I don't know
I'm
how to
okay with it, but you are fast for
the ladies.
a normal yes.
This one's I'm not taking my time to be talking plenty because there are simple things we have, like the key. What does the key do? What does the
Yes.
battery or the cell do? The cell is used to power the circuit. Okay, it is used to
Yes.
power the circuit. That's all you need to know. What does the switch do? The switch is used to open or close the circuit. When you open the circuit, it means that you have put off the light or put off the switch. When you close the circuit, it means the switch is on. Eh? That is,
Yes, boss.
those are the things I'm saying. So these things are not anything. The fuse, we said that the fuse is a thin wire which is in the circuit. And what happens is that when there is an excessive current, it will heat up and blow. So sometimes you see that you will be here like you are plugging your extension or something, then you hear pale or it's blown. And then you take it to the electrician, they'll say that, oh, it is the fuse. They'll just open a portion and then change the fuse, and then you connect it, it will come again. If the fuse was not there to do that, like that current will go direct to your appliance, which is going to damage the appliance. Is that okay?
Yes, sir.
Yes.
Yes, sir.
We talk of the wire which carries the power or the current from one point to the other. So in your house, where you are tapping the light from, if there is no wire, you cannot tap it. Is that not it?
Yes, sir.
So these are some of the things I was saying. Then we have the voltmeter, we have the ammeter. This one's, well, so you said the voltmeter is an instrument that is used for measuring electrical potential difference between 2 points in an electric circuit. It is used to measure the potential difference between 2 points in an electrical circuit. So if you go to the, I don't know, you can don't take your things to the repairers. The men do. When you go, you realize that the repairer will pick the voltmeter and then check the voltage, which they will check the potential, the difference. Then they are able to tell you that, oh, this is the fault. They will do a lot of things. So that is the voltmeter you are seeing there. This one, that is the voltmeter. And then the ammeter is used to measure it is used to measure the current in a circuit. So how much current is flowing through a circuit? This ammeter is being used to measure it.
It's even in front of the stabilizer.
Yeah, it's you see it in front of the stabilizer. Thank you. So an example of an electrical circuit. So you see, these are the resistance or the resistors. These ones you are seeing, they are the resistors, and they are what? Their main purpose is to reduce the current flow and then lower the voltage. They reduce the current flow and lower the voltage in the, so it is in every device. This thing, you will see it in every device, just that we have sizes. In every device, you will see them. In fact, if you open your charger, your phone charger, you see some of these things there. So this is
Sir,
a
please.
sample. Yes.
Sir,
So what are the passive electrical components? Components, sorry.
Oh, the passive electrical components.
Yes.
What are they? Please tell us. Those who know, tell us.
I said, please, is it the resistor? Hello, sir.
The passive electrical components, what are they? It's not the resistor alone.
But resistor is one of them, please.
Yeah. So it is an
Okay.
example. So you mean all this?
Okay.
This is talking about all the components in the circuit, all the components, the wire, the bulb, everything form part of the circuit. So those are the electrical components in the circuit.
Okay. Thank you, sir.
Please, I hope there's no question for me now. So this is a simple circuit. This is a simple circuit. You can see how the wire is used to tap the current to the bulb. Can you see it?
Yes, please.
All right. These diagrams are very plenty. This is also another example. So you can see the switch. This is the switch. So here, this switch is off. So it means that the circuit has been opened. This switch is off. So it means the circuit has been opened. Look at this place. You can see that the switch is on. When the circuit was open, the bulb is off. When the circuit is closed, the bulb is on. Can you see it?
Yes,
Yes,
sir.
sir.
All right. So let's move on. Let's look at types of circuits now. So it says that there are two common ways by which wires are connected with electrical components. The wires may be arranged in series or in parallel or combination of both. So we are talking about types of circuits, okay? In your homes, you see how you connect your devices. Sometimes you have bulbs in the home that are all connected to one switch. So for instance, your outside bulbs, okay, the bulbs that are outside your home, they are all connected to one switch. So when you put on that one switch, all the lights in the around the home or outside the home it turns on. And when you put it off, it turns off. Are you okay with that?
Yes, sir.
The same way, if you go to church or large auditoriums, you see that all the lights or the bulbs on the same line are being controlled by one switch.
Yes, sir.
Okay, so now let's look at what they mean. By that doing, we have two types of circuit. We have the series circuit and then we have the parallel circuit. The parallel circuit and then the series circuit. So when you talk about the series circuit, all the components are connected end to end to form a single path for flow or for current to flow through them. It has no branch, but instead has several components arranged one after the other. So just as I was saying, like your light bulbs, those that are in the same line and are being powered by the same switch, we say that they are in series. Is that okay?
Yes, sir.
Yes.
Yes, sir.
All right. So they said that it is like, should I even say this? It's like television series. Like you are watching a program. One episode comes, it goes off. The another episode will come. Another episode will follow. Like that. So that's how the series circuit is arranged. Now, what happens in the series circuit is that if one lamp breaks or one component is disconnected, the circuit is broken and all the components stop working. Is that okay? If one component goes off, it means that the whole circuit is broken, so everything will stop working.
So, can I come in later?
Yes, you can.
An example is the LED bulb that we used in our various homes. They are connected in series. And when one of the LED bulb goes off, it's the entire bulb will not come on when you switch it on. But it has about, I think, 10 to 15 bulbs LED arranged that comes on in the form of a series. So in this case, that bulb, sometimes I repair them. I just, the one that is off, I just melt a lead on it, and then the entire series comes back again, and then I reused the bulb rather than throwing it away. So that is the series. When one goes off, the entire thing goes off. Thank you.
All right. Please, are you okay with that?
No, sir.
Hey.
Please, have you opened the bulbs that we use, the LED, the one that comes white when you put it on? Have you opened it before, after it is spoiled?
No.
No, please.
No.
They will not open it, Mr. Emma. Let me just describe it and then we'll go. When we are teaching such topics with ladies, you have problem. So, madam, the one who said no, we are saying that they are in series. So what happens is that just imagine that you have things arranged in a straight line, okay? One connected to the other. So let's imagine that as we are here now in the class, we have a lot of bridges that we are standing, that there are bridges between us, but we are holding hands, and then anything that is walking through us can walk through us straightforward. What will happen if two components or one part of the our line decide to leave or not to hold our hands again? Are you getting what I'm saying? Let's say that we are having we are in a queue, okay? We are in a queue, and then we have a wire going through all of us, which is transferring something. And then one part or somebody decides to go out of the queue. What will happen?
The transfer will break. It will not continue to flow.
Thank you. So just like that, that is how this kind of
example.
Yeah.
Another example, when you take the children to the park for PE, and then you tell them all to hold hands and form a circle. When they hold their hands and form a circle, large circle, maybe children of about 25, they will form a very round circle, big circle. If they are holding their hands, it means that they are connected to each other. Then that is the series we are talking about. But if one person gets out from the line, it means that the other person cannot hold if they don't move together. If they move together, then they will reconnect again. But if that person that comes out from the line decided not to join, there is a space there. And that space is what we normally call the break of the circuit. It means that there will not be any connection again. It will not flow again. So that is also another typical example. Thank you.
Thank you.
I hope it is clear now. So this is an example of
Yes, sir.
this is an example of series circuit. if one of these bulbs goes off, there's a cut of power, so the rest may not. So let's say that if this one goes off, this one and this one may not work again because one of the components is not working. So you have the same thing here. You have the same thing here. It is the same thing that is occurring here. Is that okay? Yeah, somebody want to ask a question?
Yes, sir. Please
Yes.
tell us the other diagram.
I should do what?
Please tell us the other diagram. Last question there. No, the top one.
This one.
Yes. So, for me to understand very well, you said when one of the bulb goes off, the other ones will not light.
Okay.
So is it the bulb that is going off has caused the other ones, or it is the part the current is flowing? I don't understand what you said there very well.
So watch me. Can you see my pointer, my cursor? Can you see my cursor?
Yes, sir.
Yes, sir.
So you see how this cursor is moving? Look at it. You see how it is moving from here? Eh? Can you see how it is moving?
Yes, sir.
Yes, sir.
That is the same way the current is moving. From here, it will come and go through this wire, go through all this wire, and then come out from here and then meet this and goes like that. The same way this one is also coming, goes through this wire and then go through everything, goes like that. You get it? So what happens is that if this goes off, it means that immediately this bulb goes off, let's say like this. Now the flow will not be what? The flow will not be there again. You understand? Because the current that is coming is being prevented from traveling through. So the flow will not go on as it's supposed to be. Do you get what I'm trying to say?
Okay. Okay.
Yes, sir.
Yeah. Okay, so that is it.
Sir, please, from what she asked, it means that for the power on the lamp holder, the power still runs through, because the cable is not disconnected, but it is the bulb, when the bulb dies, that it will not come. But when the cable has an issue to the next bulb, that is where the issues comes in. That's the next bulb goes off, but the bulb before the next one will still be working. This happens when there is a breakage in the transformers in places that we live. If the current is being distributed from a source, and then there is a problem with one of the transformers, let's say a town A, then you move to town B, then you move to town C, and then town D. If town C has issues with the transformer, it means that town D will not have light. But town A will have light because their distribution, their source that they are taking the power from, is still working. So to answer a question, the light, the current will still be in action. The circuit will still be there until there is something wrong with the lamp holder. Before the next lamp holder will go off, the circuit will go off. So that is a little that I know concerning the question that she asked. Thank you.
Okay, so look at this. It says that if a bulb is removed, the circuit will be broken as the electrons stop flowing. You get it? So this is what we are talking about. Immediately the bulb is removed, the circuit is no more complete. Do you understand it?
Yes, sir. Because the
So that is
negative
what
and the negative and the positive are working together, just like we did last week. If
so
there
immediately
is
one,
yes, if it's the bulb is working, it means that the connection is connected. The flow is, the electrons are flowing. But when it gets destroyed, when it goes off, it means that the electrons are also off.
Madam, are you clear now?
Yes, I'm clear now. Thank you.
Okay. Please don't worry about the things I'm skipping, okay? We'll not be asking you to be doing these plenty drawings and then calculations. So get in mind what I have told you about the Ohm's law, the calculation, and then I want to talk about series circuit, what they are, parallel circuit, what they are. These plenty calculations.
Sir,
you don't have time to.
Forgive me.
Okay.
We've explained into details the series. Now, what about the parallel?
I'm not going to talk about it.
Oh, okay. Okay. Thank you.
Yeah, because I have skipped about 3 slides, which has a lot of diagrams and then calculations. So this is the parallel circuit. So this one is a type of circuit that has different pathways. Okay, the members have different pathways, and so current flow through them in different dimensions. So here, just as we're using the bulbs, for example, these are all having different pathways. So in fact, if there is a breakage in one, it doesn't affect the other. Is that okay? If there's a breakage in one, it doesn't affect the other. So it says that in a parallel circuit, different components are connected on different branches or different branches of wires. Thus, if a lamp breaks or a component is disconnected from a parallel wire, the components on different branches keep working. Unlike the series circuit, the lamp stays bright if you add more lamps in a parallel circuit. So the series, if you continue to add more bulbs, you see that the brightness of the light will start dimming, it will start going down. But it is not like that in the parallel circuit, because the components are connected through different pathways. So let's look at this diagram. Mr. Emma, now this is the diagram that will clear the, I think the ladies issue very well. So you can see this.
Yes.
So here, now the current itself is flowing through a main wire. Can you see it? It's flowing through a main wire. And then some wires are being used to trap this current to power this bulb. So this wire and this wire they are tapping current from this wire to power this bulb. So when there is a problem within these two wires and then this bulb goes off, the main wire is still working. You get it? So it will not affect these two bulbs. Please, are you with me?
Yes, sir.
And so what happens is that if we should still continue to add bulbs to this, there's not going to be any decrease in power or in current, because the main wires are still there. They are supplying what they are supposed to supply. All these ones are just tapping from it. Does that make sense?
Yes, sir.
Okay.
Can I come in a little?
Okay.
What I want to say is, with the parallel, let's take for example, our homes. If we call an electrician to wire our houses for us, it's either they wire it in a series way or in a parallel way. When we talk about the series, it means that one will be tapping from the other. So if the power source is coming from room 1 and then the room 2 tap from the room 1, it means that when the room 1 gets issues with its socket or its main line, it means that it will affect room 2. Room 2 will go off. So at times your light, the person before you, light goes off, and then your light also goes off. And that is the series. And then the parallel is when the various rooms take their power source from the main switch, and they have their own switch in the main switch. That one, if one room goes off, because they are taking the power from the main switch, if one room goes off and you have problem with your socket, the other room still have light. But if you tap from that room, when it goes off, you will also go off. So in this case, the parallel uses a lot of cables. And we normally, Ghanaians, we don't like that one because you'll be buying a lot of cables. But that is the best. That one room will not depend on the other when there is a power issues with one room. So that is a little explanation too that I can give on this, in the two. Thank you.
All right. Please, I hope you are all clear with that.
Yes, sir.
Somebody is saying something.
Hello.
Yeah, I can hear somebody say something. Somebody says science has done what? Linda, you said science has done what?
Hey, sir, forgive me.
Okay.
Elizabeth,
talk.
Please,
we tackle from the electric pole. So house A will tap it from the same pole, house B from the same pole, house C from the same pole. So if maybe house A light goes off due to some problem, house B and house C will still have light. So can I equate it to that angle?
So what happens is that you see if house A is tapping from the same pole, house B is also tapping from the pole, but not tapping from house A. Okay. If you are also tapping from the main pole, but you are not tapping from house A, then when there is problem with house A, it is not going to affect you. But if you are tapping from house A, whilst they are tapping from the pole, then when there is a problem, it will affect you.
Okay. Thank you.
Yes, Vivian.
Sir, please, so I think the problem starts from the transformer, because with the transformer we have phases. So it depends on the phase that the area, like you can be in the same area and a phase goes off and a different phase will be having light. So I don't know whether if it is parallel from the transformer that is causing that.
Please, this
sir, please do get me or she come again.
When we are talking about parallel and series circuit, let's limit it to the house alone. We shouldn't have to go.
Okay, we shouldn't go to the transformer. Okay.
Yeah, let's
okay,
limit
thank
it
you.
to the house alone so that we get the understanding. Because if you are going to the transformer, we'll be going through a different thing altogether.
All right, thank you, sir.
Yeah. Who else? I think that is all. So let's move on. So electricity, when you have everyone. Okay, so it continues like that with these plenty things. Now let's look at the different states of a circuit. We have open circuit. What is an open circuit? This one I've said it already, so I'm not going to say it again. What is an open circuit? Let's talk. Sandra. There are people who are not talking. I'll be mentioning their
Please.
names.
An open circuit
Hello.
is a circuit that has been switched off.
Okay. She said it's a circuit that has been switched off. Yes, Kate.
Yes, I had wanted to add to say the same thing, that it's a circuit which current is not flowing through, or there's a breakage in the flow of current.
That is very nice. Elizabeth, your hand is down. I think you want to say the same thing, right? Maybe it's what you want to say.
I wanted to say that it means that your switch is off. So the current is not flowing.
Okay. So that is it. So it is a current where it is a circuit where there is no energy running through the circuit, either by design or through a fault. So sometimes it can be through a fault. Maybe when there is a fault, the circuit can be open, and sometimes you yourself can keep it off. So if it is by design, it means a switch has been opened. So you have turned the switch off, just as you said. But if it is with a fault, then it means that there is a fault that has occurred. And for that matter, the circuit to be left open. For instance, if the fuse blows off, the circuit may be open because it may not on again until you fix that fuse. Is that okay?
Yes, sir.
Yes, sir.
All right. So you can see here, this is an open circuit. The switch is off. The switch is off, so it's an open circuit. And then this is a closed circuit. So the closed circuit is where energy is permitted to run through the switch, usually when a switch is turned on. So you can see this one, that this one, the switch is on, so the bulb is on. This one, the switch is off, so the bulb is off. So this is an open circuit, and this is a closed circuit. Then let's look at what a short circuit is. So a short circuit is a connection on an electrical circuit, uninsulated wires into bracket, that allows current to flow in an unplanned or accidental path. Okay. This one, in an unplanned or accidental path. So when you talk about short circuit, there are some connections that are being made, or some wires that are being added to the connection, which in case of an accident or in case of a problem, they will prevent this current from flowing directly to where it's supposed to go. So you are seeing an example here. And then another example I was talking about is the use of the fuse. And sometimes we have the earth wire, which we say that when there is excess current, it draws some of the current into the ground. Is that okay? Hello?
Yes, sir. Yes, sir.
Yes, sir.
Another example is for us living in the villages. When there is a rain, thunderstorm, and then a tree falls on the electrical cables. When the two cables, which is negative and positive, they get together, it means that there is a short circuit, and that puts all the lights off. Thank you.
Yeah. So we have different states of a circuit. The interference. So when there's an interference, like Mr. Ima said, it destabilizes the functioning of the circuit, and that makes the circuit becomes unfunctionable. It cut off the light and then prevent the light from working as it's supposed to be, just as he was using the example. Sometimes too, even in our homes, if the person doing the connection, or sometimes you yourself, you mistakenly happen to bring two wires together. Sometimes when we have gadgets or appliances that are faulty, appliances or gadgets that are faulty, or extensions that are spoiled, and then we try to use them, we cause some of these problems. We cause what is called a short circuit. So you realize that you plug in your extension and then you put it on here. Before you realize, boom, then this thing will go off. The extension will go off, and then the main switch over there will also go off. Have you experienced such thing before?
Yes, sir.
Okay, so that is what we are trying to talk about. Now we have types of short circuit. We have the normal type, and then we have the ground fault short circuit. So the normal short circuit is a type of circuit where hot wire touches a neutral wire. Immediately the resistance drop, and then the current begin to move in a different pathway. So when a hot wire touches a neutral wire, the resistance will drop, and then the current will begin to move in a different path or in a different dimension. Then the ground fault short circuit, in a ground short fault circuit, a power or a hot wire touches the ground. Sections of a box, device, appliance, outlet, bare ground, and so on and so forth, or anything else which supply the electricity. So as I was saying, just like I was saying that you use the extension, okay, you plug in the extension and then it blows off. So any device at all that you connect to the device to the circuit, and then it will cause the circuit to blow off. We call it the ground fault short circuit. It could be any appliance, any device, any box, any outlet, or bare ground. Anything else that can supply this kind of electricity or current. When there is a fault or there is a torture in there, the whole circuit would have to turn off. And that is what we call the short circuit. What causes short circuit? So we have examples here. And this one, the examples, I don't think I have to be explaining them because they are simple things you can read and understand. Or you want me to talk about it?
Briefly, sir.
Yes, sir.
I should talk about it.
Yes, please.
No.
Okay, so we have, for example, vermin or pest chewing through wires. So when you have a pest, okay, that chew wires, when they chew through wires, normally they chew the rubber, what you call the insulator, on the wire. So when they chew that insulator on the wire, now they expose the wires to each other. So when these wires touches each other, this could happen because now there's no insulator to prevent the current from flowing to one wire to the other. So when the wire is exposed by pest, when they chew it. So remember, sometimes you leave your extension in the room. Normally, if food items or something like food is on the wire, this pest will come and chew the wire, and before you realize, boom, it will cause a problem. Sometimes even on the ceilings, these rats and things can go up there and then chew the whole wire. They will chew the rubber on the wire. So immediately there is something, a small shake, and these wires come into contact. It will blow off, and then the circuit will be shortened. Then we have water or fluid coming into contact with electrical wire. So when you allow water to come into contact with this electrical wire, such a thing could happen. Then we have loss of connection in an electrical bus, loss of connection. So if, for instance, sometimes the wires are there, but maybe the screw that are used to tie the wires become loose, so the wire would remove. And if this wire remove and unfortunately touches the other one, it could also lead to this problem. I hope it's okay. The rest you'll be able to understand them so that we can move fast. You have to finish this and start another topic. Hello?
Yes, sir. Yes, sir.
I hope the examples
Okay.
I've made you can relate, right?
Yes, sir.
So these things are there. Now let's look at the functions of the different wires we find in the in wiring. When they are going to wire our various homes, there are different wires that are being used in wiring. All these wires have their role to play. They have specific roles they play in the circuit. So it says that the electrical wires that binds our home together comes in an array of colors, which signifies the function of the wire in a circuit. It is incredibly important to know the function of the colors coated that cover the copper conductor of wire before starting any kind of home wiring. This thing, people do not do home wiring, but those who do the home wiring, it is important for them to know the significant role played by each wire before they go into the wiring. Note that all electrical wires, regardless of their function, may carry an electrical current at the same point and should be treated with equal caution. So now we have the wires. Black wire, what does it do? It carries current from the power source and transfer it to switch and outlets in all circuits. So the black wire carries the current from the power source and transfer it to all other parts of the circuit. It indicates that the wire is live and therefore hot. It indicates that the wire is live and therefore it is hot. Then we have the red wire. It is used for switch wiring and for the interconnection between smoke detectors and hardwired into the power system. So they are used as interconnections between smoke detectors, and they are hardwired. They are, how do I say it, intertwined, or they are connected into the power system. Since red wire conduct current, they also indicate hotness because they can also conduct, or current can flow through them. You consider them to also be a hot wire, or they have some level of hotness. Then we have blue or yellow. It's used in complicated circuit. When I say complicated circuit, it means that the circuit has a lot of wires coming together. So it is used in complicated circuits and are used as hot wires to conduct current between switch and poles, also known as the travelers. Yellow wires are used as switch led to ceiling fans, structural lights, outline pair, whatever. Oh my God. It also indicates, so now pick the points, simple. The first one carries current from the power source and transfer it to the switch. The second one is used for interconnection, and it's also used between smoke detectors. Okay, it is used to detect smoke. And then the second one is used when the wire is, or the wiring is complicated. So you realize that this thing, you people do not do wiring. I don't know how well I can go about it. Mr. Ima, do you do wiring?
Please come again. Wiring
in the house. Have you done some before?
Yes, I do that.
And then
so I was coming to that, so that I will also explain a little for them to understand.
Yes,
if someone is also finding it difficult.
In fact, if you are explaining it, they will not understand because they cannot even relate. They have not even, I don't know. Has any of you
try your best? Do your best. We will understand. Do your best.
Because the table will be different from the one that we normally do at our houses. Because what I know is red wire goes with the brown, the same as the brown, which is the life.
Yeah.
And it's the same as the black. which is also life. But
I
you
see.
come to white, blue, and then they are the neutrals. And then the green and then the yellow are for the earth. So what I'm saying is when you open your plug, it's either you see red or brown with the blue. And then with the yellow, if it is 3 cables in one coil. So it's a little difference from the table, and that's what I was watching. Even in our books, they limited us to, in the books, they have limited the carrier technology, they've limited it to the plug cables alone.
Which are how
the
many?
one we normally use at home. I think it is part of it, is on the slides. The last time I saw it on the slide, a opened plug. Yes,
Okay.
this one.
Okay, so let's hurry up and then we'll get to that.
Thank you.
All right. So these things are all just, I don't know. It becomes difficult when you want to explain it to, especially ladies who don't go close to any. If I tell them that, have they even opened the this one like this? Has any of you opened something like this before? The ladies?
Yes, sir.
Yes, I have.
Yes, sir.
Yes,
please.
I've changed
So
my
what?
iron several times.
You've changed your what?
My iron plug, when it spoils, I buy and change it.
Oh, I see. Okay. So you see, this is the fuse,
Yeah,
right?
you think we are not so hard that we normally do some. We
Is
think we
that what?
don't do them. We do. I said we do
Then
them.
you people, you people are different.
We underestimate them.
It's
People are
not all of
different.
us. Oh. It's not all of us.
Some people will not do it. They are scared. Some people, even when they are opening the switch without light added to it and something past their body, now they'll say it's electric shock. Okay, so you see, typically, this is something like what Mr. Ima was talking about. Can you see it? So the blue here is neutral, the yellow or the green becomes the earth wire, and then the brown here becomes the, what do you call it? The live wire, okay? So this is typically what we want to talk about. So let's know what they do. The earth wire has its own role. The live wire has its own role. The neutral wire has its own role. And then we also have the fuse, which also plays a role in the circuit.
Sir.
Yes.
So sometimes you also find black wire. What's another name for that one?
So that is why Mr.
The
Emma
black,
was saying that.
yeah.
Okay.
The
Mr.
black
Emma,
is also life. You find the black with the white. The white is neutral, and the black is life.
Okay.
All right. So before then, we may have to do this calculation. Is that okay? We may have to do this calculation, but then I'll skip it. And then we'll go and finish the whole thing. Then we'll come and focus on the calculation. You agree with me?
Okay, sir.
Yes, sir.
Yeah.
Yes, sir.
If we start with this calculation right now, we may not go forward again. All right, so let's look at what energy conservation is. When we say energy conservation, what does it mean? This one, you share your ideas and then I'll move forward. I'm not going to waste time. What is energy conservation? Yes, energy conservation. What is it?
Bless.
How to use energy wisely without causing any environmental impacts.
So how to use energy wisely without causing any environmental impact? Well, that is okay. What else can we say about energy conservation?
Akosia.
No, say energy is managing energy in order to reduce the wasteful use of energy.
Okay, so you are managing energy wisely to reduce the
Wasteful use of it.
Okay, so that is it. Energy conservation is the wisest way, or the word is not even coming. Energy conservation is using energy wisely in order not to what? Waste it. You get it? You are using it wisely in order not to waste it. Now, what are some of the activities we do that shows that we are conserving energy?
Adepa.
Yes, sir. When we iron clothes in bulk, we reduce the wasteful use of energy. And secondly, if we engage ourselves in manual activities, instead of engaging ourselves in everything we want to use electrical waste, if we engage ourselves in manual activity, it's going to reduce the wasteful use of energy. Closing our deep freezers after using it, sometimes we take something from the fridge and leave it open. We are wasting our energy. Thank you, sir.
You're welcome.
Please, can I come in?
Yes, come in.
I want to add up, but I want to tell our sister that this time we live a free life. We want to be comfortable, so we have to use electricity, but only that we have to use it judiciously. We wouldn't waste the energy. So maybe if a gadget is not in use, we have to put it off. Anytime a gadget isn't in use, we should switch it off, and it will help to conserve the energy.
Okay, some people said we are in a modern world, so we have to use the gadgets. Okay. Yes, let's go on. A lot of hands
Eunice.
Okay, well, we have 12 electrical appliances. We need to repair them.
Okay, so when you have sports electrical appliances, you need to repair them. What else? What else? I can see Rebecca. Rebecca's hand is up.
Turning off the switches when not in use. Then also making
We
use
shouldn't
of
put
daylight.
That is it. So in the day when your room is bright enough, just put off the light, and then just think about using the light always, and then put off your appliances. That is okay.
Okay, sure.
That is good.
Felicia. Celestine. Okay.
Please,
we can
let's
we
continue.
can also
Okay.
conserve energy by using sensor bulbs.
Okay.
So the sensor bulbs, when you are not in the room, it will detect that there is nobody in the room, and then it goes off by itself.
Okay.
Hello.
Yes.
Felicia is talking. So we should be.
Felicia, talk.
Hello. I'm saying.
Felicia, you normally goes off when you are talking. Please come again. You went off.
Hello.
Yes,
And
Felicia.
I think we should also be mindful about buying electrical gadgets. Like this modern fridge, they don't waste more energy than the older ones. Hello, I'm talking. I'm saying that.
Yes, we get you. We
Hello.
get you. We understand you.
All right, so let's continue. Is that okay? So what are some of the things we are supposed to do to ensure safety in the use of electricity in the home? Mohammed. Mohammed is not talking. Blessing or bless.
Hello.
Yes.
Yeah. So I think if you are not in use of electrical appliances, we need to put them off.
Okay. That is true. Yes, Akosia.
Say, I think we should not operate electrical appliance with wet hands. Thank you, sir.
Yeah. So we should not be touching appliances with wet hands. Yes.
Also, we those who use extension sockets, we don't have to be overloading them, since it might even cause sparks, which can lead to fire outbreaks.
Okay, so avoid overloading your circuits. That is true. What else?
Then again, you should give your electrical gadgets to a qualified person when there is an issue with it. Don't temper it yourself if you have no knowledge in it.
Sure. So don't go and then be operating it. You say that, oh, anyway, the person who has been changing the iron, this thing, make sure you give it to the repairer to do it for you and don't be changing it. It's dangerous.
Yeah, I have raised my hand
And
for
also,
like
once you realize that your appliance is faulty, you don't have to use it.
Yeah, it's true. Somebody says she
Sir,
has
please,
raised
I
the
have a
hand.
question.
Okay, Mabina.
Yes. Sir, my question is, hey,
Okay, Alaji, please mute for us, eh? Yes, Mabina, we are listening.
Can you talk like?
sir, please, I have understood my question.
Mabina, we can't hear you.
Please, I have
Mabla said
understood my own
she
question.
now understand what she was about to ask.
Oh, okay.
So we can continue.
So when you talk about it, yes.
Sir,
Hello.
please, I didn't hear it well. You said that when our appliances get spoiled, should we throw it away or should take it to the repairers?
I said you should take it to the repairer.
Okay. I fed you. Thank you.
Don't repair it yourself. That's what I said. I didn't say straight away. Okay.
Okay.
So we are looking at 3 plug pins.
Please, I have a
Yes, ask. Yes, the person who says she has a question, ask. We are waiting.
no. I also have a point to make.
Okay, make the point.
On the safety side, I was going to say that we should not bury wire on the ground.
You shouldn't do what? Bury wire.
On the ground, some will do the connection through the ground to the household.
Yes, it's very true.
It's very true. It's very dangerous.
Very true. Yeah. Okay, so let's move on to look at 3-pin plugs. What are 3-pin plugs? So these are the plugs that typically we use in Ghana here. You realize that they have 3 long pins that you insert into your socket or your whatever. And these plugs are designed to make sure that they help you work very well, and then it is also safe. It is safe and then reliable when you are using it, unlike the 2-pin. In a 3-pin plug, if a live wire touches the metal body of the appliance, a large current will immediately flow to the earth and then breaks the fuse. So it will break the fuse and then the fuse will blow to prevent the electrocution. Unlike the 2-pin plug, when that happens, it will electrocute you because there's no fuse, there's no live wire there that will blow. But then the 3-pin plug have a live wire which will make this happen, and for that matter, it will prevent electrocution. Is that okay? So let's look at the 3-pin plugs, the wires that are there. We have the green wire, which is the safety wire connected. It connects appliance to the earth. This is connected to the earth pin. This is used when the appliance has a metal causing short. So what is trying to say is that when the live wire comes into contact with the, I'm coming. This is not making sense. This is, please hold on, I'm coming in.
Okay. I said I want to add a little thing to it. The person who normally change the plug itself, what she needs to know again is normally when you look at the plug inside, they've written L and then E and then N. So the N is the neutral, the L is the life, and then the E is the earth, so that you don't mix the cable where they goes.
Oh
After
yeah, I'm very aware of
identify,
it.
yes, after identify with the colors, and then you look on where the goes, and then you don't mix it up.
Sure.
Thank you.
Thank you too.
All right, so thank you. What I want to say is that, you see, so the earth wire, what it does is that it is in the plug to prevent you, the individual, from being electrocuted. When there is a problem with any of the wires in the circuit, or when there is a problem with the circuit itself, this earth wire is going to help you or prevent you, the individual, from being shocked or having shock. Is that okay?
Yes, sir.
Yes, sir.
All right. So let's move on to the, I want to finish this thing early. Then we have the live wire. So the live wire is connected to the fuse on the live pin. So the electric circuit routine routes through the live wire. So the live wire is also connected to the fuse. And I've told you what the fuse does, right?
Yes, sir.
Yes, sir.
So it's connected to the fuse. So in case of any fault or any problem, the live wire would divert the current now to the fuse, and then the fuse will blow off. When the fuse blow off, it will shorten the circuit. It will make the circuit becomes short. And when the circuit becomes short, it prevents the flow of electricity now through the circuit, and for that matter, prevents further damage. Then we have the neutral wire. It says that it works as the conductor for electricity to flow through the circuit. It works as a conductor for electricity to flow through the circuit. Its main purpose is to complete the circuit. It also keeps the flow of the current to the main source. So this carries the current to the main source, and this allows electricity to be fully utilized. So it is the neutral wire which allows you to use the electricity in the house. So when you put in the plug, the neutral wire is what is going to carry the current and then power your devices. Okay, so we have this, we have that. We also have this. Is there anything else you may want me to talk about here? These ones are all diagrams. They are there for you to see, right? Hello?
Hello, sir. Hello. Hello, sir.
The way people are quiet, it's like I'm going fast, and so you are not happy.
No, it's
Hello,
okay.
sir.
Yeah, okay.
Because this
Hello,
is
sir.
yes.
Fine. Sir, Please, I want to find out why these 3 pins, certain times, they get stuck. When you plug them and you want to take it off, it gets stuck. What really happens to it?
That would only happen when there is a problem. Sometimes when the socket is faulty, it sometimes even melts the pin itself in the socket. And for that matter, when you are trying to take it off, it becomes difficult. And sometimes to look at the design of the pin before you see the socket you are going to put it inside. Because some of the pins have specific sockets you are supposed to put them inside. For instance, some of the pins are round, some are flat, and we have different shapes. So look at the shape of it first, and then consider the shape before you put it into such a circuit. Because if you don't take time and then the thing is not fitting and you push it there, definitely when you are going to remove it, you suffer.
Very
Thank you,
necessary.
sir.
So there are some few questions here for you to answer, but not now. You answer them later. Let's come back to this calculation. So now look at what is here. The rule is very simple. The instruction is very simple. For you to be able to calculate the amount of energy or electricity you use in the house, first, what you are supposed to do is that you find the electrical appliances voltage. You find the voltage of the appliance you are using. And after that, you estimate monthly use in hour. So power and time or duration of use. After you have done that, now you go ahead to multiply the appliance voltage and estimate monthly use to find what hours they are being consumed or how many hours they are being consumed. And you call that one wattage hours or watt hours. When you finish, you divide the watt hours consumed by 1,000 to find the appliance's total kilowatts. Total kilowatt per hour consumed. And then after that, you add the monthly consumption of all the appliances together to find your total electricity use. This is very simple. So when you take your appliance, the first thing you have to do is to check the voltage. So, for example, calculate the cost of an electricity for an air condition of, so on the air condition, they will indicate this number of wattage, or on the appliance you are using. So you see that those days when we are going to buy bulb, I don't know, those days when I was
Yes,
in the
sir.
village, when we are going to buy bulb, they'll
50
say that you
watts,
buy 20
100
watts,
watts.
40 watts, 30 watts. And do you remember?
Yes, sir.
Yes, sir.
So
Yes, sir.
this is the wattage, and then this is the amount of hours that is being used. So in 7 days, it's used for 4 hours. Okay, 4 hours in 7 days. So it means that every day 4 hours, 4 hours. So 4 times 7. There is nobody here. So let me go straight to the calculation for you. So this is the
28.
solution. Is that?
You asked 4 times 7 and I said 28.
Okay. So this is the solution. So the first instruction says that we should find the energy consumption and multiply it by time. So the energy consumption is the watt. That is the 170 watts that we spoke about. And then we said that they use it how many hours? 4 hours for 7 days. So 4 times 7 is 28. So what you have to do is that you multiply the voltage by the hours of use. And so this times this will give me 47,600. Okay, 47,600. Now, after I have gotten this, I have to convert this from wattage per hour into what? Kilowatt per hour. So this one would have been WH, which is wattage per hour or watt per hour. But I have to convert it from watt per hour into kilowatts per hour. So I will multiply it by, I'll divide it by 1,000. After dividing by 1,000, I get 47.6 kilowatts per hour. And then now from the question, it says that the cost of consumption per unit is 50 pesos. The cost of consumption is 50 pesos. So I'll multiply the whole thing by 50 pesos. And it means that, so if I use this for 7 days, if I use this AC for 7 days, 4 hours for 7 days, I'll be paying 33 cedis, 80 pesos as power usage fee. So let's go through the process again. Find the appliance, find the electric appliance wattage and estimate monthly use in hour. The first one, that is what we did. That's 1,700 watts. And then it says that you should multiply the appliance watt estimate. Apply the, oh shit. Multiply the appliance watt and estimate monthly use to find the wattage hour consumed. So you multiply the wattage per the number of hours that is being used. And this is what you are going to get. This is what you are getting. After that, you convert it into kilowatts. How do you convert into kilowatts? You divide by 1,000. And then after dividing by 1,000, you multiply the whole thing by the unit cost, which is 50 pesos, as it is here. Now, I'll give you a different question. You will solve it. When we meet next week, you will let me know the answer you've gotten. Or let me see if even you have some down there so that you use that one instead of. Okay, there is none here. So let's take this assignment. Are you seeing my screen?
Yes, sir.
Yes, sir.
Hey, I can't see you.
Is he the only one who is not seeing?
So I can't
So
see.
me too, I can't see you.
So
Don't
I
worry.
can
Hmm.
see.
Not
Mm.
so
It's just
sorry.
written as mine.
So we are
Yeah,
only seeing us.
you're only seeing aside.
It is from their side because we can see. It is from their side.
Yeah. I'm now trying to give you the question. So I'm going to create a question for you to work on. Calculate the cost of a blender. Can you see it?
Yes,
Yes, sir.
please.
Okay, so that is the assignment I'm giving you. So follow the procedure nicely and then use it to answer the question. Is that okay?
Yes,
Hello,
sir.
sir. On the calculation side, we didn't hear anything. No network problems.
from calculation side, I didn't get anything. I've sent you messages, several messages.
You've sent it to me.
Sir,
Hey,
please
the
kindly
way the
highlight
particulars, you don't know
the
how a blender looks like. Oh.
You don't know how a blender is like. Somebody say he doesn't know what
I mean, with the
blender is.
particulars. I mean, with the particulars.
But you don't need to know what blender is to be able to answer this question.
You come from a family. You come from a family. You come from a home before.
Hello?
Sir,
Must you get married
Yes.
before going blender?
sir,
Hey,
please,
sir.
should we always leave the final answer in kilowatts?
If you are calculating for cost, it's not supposed to be in kilowatt. Oh.
Please come again.
I said that if you are calculating for cost, look at the solution here. You are calculating for cost, so it should be in Ghana cedis.
Yes, change of subject.
Okay.
You are calculating for
You can
cost,
be
so
acts of kilowatts. Or say,
is that?
Can you also be acts of kilowatts? Or at times the question will also demand for hours or days that.
Then maybe unless you are giving the cost, maybe they can give you the
Yes,
cost and
you'll be
then
given
they
the
can
cost.
give you
Yes.
other things and they'll ask you to calculate for. But it is rare. It is rare for you to see that.
Oh, okay. Okay.
Yeah.
Thank you.
Thanks.
Yes.
Please, is there a formula, a stated formula you can follow? Because this one, when I read, in fact, it's confusing me. So if there is a stated formula, this is equal to this, and you want to find this, you follow this formula so that it will be quite easier.
It is the same formula. You just look at the calculation that is being done. Okay? Look at the calculation that has been done. Follow the calculation. Okay.
Sir, can I come in?
Yes, you can.
If you look at the solution, it means that when you are looking for energy, energy is equal to power times time. I don't know whether I'm correct.
We want to eat pepper. What do you know? I want to eat pepper.
Sir, please, the
Want to
first
like.
question. You want the slide? No, you didn't finish writing.
Yeah, very true. I think the slides will be of help to us.
But you have the slides already, apart from this question I just added.
Yeah, that's what I wanted to ask. This one.
Somebody wants us to help you. The day I want the verses to sound cool.
Oh, talk. I'm listening.
Mom.
Sir, I also have a formula here from what we discussed earlier. That is the EC is equals to P times T. That is energy consumption is equals to power times the time that you have used. And then
So you might come again.
EC is equals to P times T. That is energy consumption is equals to the power times the time, the period that you have used. And that is normally when you look at our electricity bills, it is written there, kilowatts per the consumption. It is written, I think, at the top on the table that they have it on our electricity bills. They've written it there. So you take that consumption, you multiply it by the units per cost, one cost of unit, and then you get to know the amount that you are paying for a month. And if you are there and you don't check on this, sometimes these electricity people, they can write different things for you, and you'll be paying bills that you are not supposed to pay. That if they come and then you are able to show them this and talk to them concerning these calculation and everything, they will get to know that you know what you are saying, so they will not bring their matter to your doorstep. And then we also have CE is equals to TC times UC. CE over here is the cost of electricity. The cost of electricity is equals to the total consumption times the unit cost, for which I said right now. So if you're able to get this formula, you'll be able to do your calculation.
So, Brahima,
yes.
Please, the question that say asks us to calculate the cost for blender, what be the formula to calculate it?
We are using what he gave us right now.
That calculate the cost for blender of 150 watts.
1,500 watts.
It
has been used for 5 hours.
5 hours in 14
days. It has been
days.
used for 5 hours in 14 days.
14 days.
Yes. So you take the 1,500, multiply by the 5 hours, and then you get your kilowatts.
But the 5 hours in 14 days, it means that 5 hours times 14.
Yes.
Wait. The thing is 1,000. The example is 1,700 by 4 hours in 7 days. The 7 days, you use that one. We have cost of electricity, total consumption times the unit cost.
I'm saying that the second question we are now solving, we are about to solve, is 5 hours in 14 days. So we have to multiply the hours by the number of days.
Yes.
Before you can equate it into what you say.
So 5 times the 14 days. So 5 by 14. Is that what you're saying?
Yeah.
Yes, please.
So then you use that one
70
to multiply. Yes, you use that one to multiply the 1,500.
Okay. Yeah.
And then the amount you get, you divide it by the 1,000, and then you get your kilowatts per hour.
Yes. Then you multiply it by
and then you use that one. You use that one again to multiply your zero.
By 1,000.
Then you get your final answer.
Which is 73.5%.
So this I will not multiply. We are not changing it to kilowatt, so we will not divide it by 1,000.
You will divide it.
You divide it first.
Please,
okay. Before we multiply by
the price.
Units.
Hello.
Yes. You divide it.
Yes, sir.
Yes, sir.
We are not doing the assignment here, so when we close,
thank you.
Each other so that we
okay. We'll
so
do
we
that
wanted clarification. We wanted clarification. That's why. Thank you.
Thank you, sir.
Okay, you're welcome. So, Mr. Emma, I'm going to share the lecture 5 and lecture 4 with you right now.
Okay.
I don't even know if we can. How many weeks are we supposed to meet?
Well, how many
weeks? This is the 3rd week of meeting.
I think it's 4 weeks or so.
So, like, we are ending class next week.
I believe so. But I'll cross check. I believe so because we have a quiz coming on. I think it's at the middle of this month. Yes, sir.
Right there. I gave you paper to write.
I need to go prepare for the quiz.
God there.
So we want sample questions. So
Hey, sample students and sample questions. You're always sampling. You are not done sampling. Never.
we want to try our hand on it to see how
Hey.
far we have gone with our studies.
Are you? Hey, what musician is that?
Elizabeth.
Your baby is giving us tracks.
Okay, so sir, on the 22nd and on the 23rd of November, we'll be writing the assessment. That is a quiz.
Okay. Hey.
And then
22nd
22nd and 23rd.
Okay.
And then 29th to 30th of this month. And then on the 6th to 7th, we'll be writing our exams.
6th to 7th of December.
Yes. 29th to 30th. We'll write, I think, 2. And then between that, and then 6 to 7, we'll be writing the second 2, making the end of the semester exams.
So, which means that after next week, we have another week to meet before you write the quiz.
Yes. Yes, we have another week.
Okay.
On the 15th and 16th, we have practicals that we have to meet face to face for all our centers.
Practicals. Where
yes.
is science part?
They've not written it there, but I think it will be our main course, which will be nutrition and health for us, and then fashion people to have this.
But nutrition and health rather do not have any practical aspects.
That's what
we have a lot of
nutrition and health.
Yes.
What practicals is that?
They didn't indicate the subjects which the course. They didn't indicate any course under the practical, so we don't know which one we are going to take.
They've only written practicals. But for my mind, so far as we are doing everything online, practicals there, it will be maybe our main subject that we are running, the major subject that we are running individually. So we'll finish our block 1 by 14th of December. And then 20th, we start with block 2.
Okay. Hold on. Let me send you.
Hello.
Hello, we are here. We are waiting
Good
for.
time.
You said?
Today, no break. It's almost time, so we are not going for break.
No break.
Okay.
We have 25 minutes to end the lesson.
Okay.
Who asked for the break?
Grace asked for the break.
Gracie.
I've
But
used my
Grace,
sister's lesson.
Grace, we wasted at least 1 hour of our time.
Yes,
So,
yes.
So going for break will not be advisable.
Don't worry, we have even filled our pots.
Zema?
Yes, I've received them, boss.
Okay.
So, colleagues, it is on the platform.
I think there'll be the sit one. I'll share that one with you.
Okay. Please, have you received them?
Yes,
No,
please.
please. No, please.
It is on the platform. I just put it there.
I've seen it.
Hello, Seima, please, which platform? Please, this is the one for only Sunyani.
Interscience.
No,
Interscience.
it's science. Interscience.
Okay. Okay, let me
For
check.
that one, all of us are on it.
All right, okay.
I am not on that page, so I'll be very grateful if the link can be shared on the Jenga platform so that I can join.
Okay, I'll do that, boss. But which one are you? If you are not on any one of them, then unless you give me your number or you take my number, then I'll add it to it. If not, I can put the link on.
All right, sir.
Is it the pages
Maybe.
created by Switch or another
No,
page?
this one is different. This is another
No,
page. We
I'm not
created
on
it
it
the
either.
first time.
So
Okay, so
We
please
Maybe
give
created
the
it
link
the
can be
first
us
time.
your contact so that we hire you and then you know what to do next.
I'm trying to see even if I can put it on this platform that we are on right now. Okay, you just take my number 0245. I will type it at the chat side.
0245.
Please go to the chat side. It is there. The chat room. Please, have you seen it?
Yes.
Hello.
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 Saima?
Yes, madam.
Saima? Please, what you are sharing, is it the lecture note or what?
The one the lecturer asked me to give to you right now. The one that contains the assignments that he gave to us to solve.
So you are placing it on our integrated science platform?
Yes, it is there right now.
Okay, you. So have we end this lecture right now?
No, we are waiting for the tutor.
Okay.
The lectures will end at 11.
Okay. Yeah. Thank you.
Okay,
And
so
then
please.
the next lecture starts at 11:50.
Okay. Yeah. Thank you very much.
Saima.
Please, we have
Saima.
not end the lessons, so let's wait.
Saima, I want
Boss,
to ask you a question.
boss, we are here.
All right, so now we are moving on to lecture 4. We are going to look at the nomenclature of microorganisms, okay? Nomenclature of microorganisms. When you talk about nomenclature, what it means is the naming it's naming of microorganisms, actually. So we're looking at the taxonomy. The first objective is that we'll look at the taxonomy of microorganisms. We'll look at the principles of microbial classification. We'll also identify the origin of names of microorganisms. We'll outline the order of naming of microorganisms and identify the rule for naming microorganisms and describe the characteristics of microorganisms. Is that okay? Now, when you talk about microorganisms are small organisms. They are minute organisms that we cannot see them with our naked eyes unless we are aided by a microscope. So we don't really see these organisms with our bare eyes. We can only see them under a microscope. So we can have organisms such as bacteria, fungi, algae, viruses. These are all microorganisms. Now, nomenclature of microorganisms. So we have the nomenclature talks about the science of classifying organisms into hierarchy groups. In science, the act of classifying microorganisms into hierarchies or groups, we call it the taxa. That is why we are saying that we are looking at a taxonomy. It's known as the taxa. So we are looking at the taxonomy. Taxonomy means that we are going to classify microorganisms based on a specific hierarchy and then names or groups. Taxonomy consists of classifying new organisms or reclassifying existing ones. Taxonomy of microorganisms has undergone many phases, starting from Aristotle. So from these big scientists, their time, microorganisms have been going through grouping, naming, or classifying for a very long time. So microorganisms are scientifically recognized using a binomial nomenclature. That is two words referred to as the genus and then the species. So binomial nomenclature, I told you nomenclature talks about classifying and naming of something. So we are naming or we are classifying microorganisms. We are saying that in the classification of microorganisms, we use a binomial nomenclature, which means that we use two names or two words come together to name a microorganism. So they are referred to as the genus and then the species. So we have genus name and then the species name when we are naming microorganisms. Now we come to taxonomy itself. It's a branch of biology that classifies all living things. Taxonomy is the branch of biology that groups and names organisms based on studies of their different characteristics. Biologists who study taxonomy are called taxonomists. Taxonomists. This system was developed by the Swedish Botanic Carolus Nalius, who lived during the 18th century. These ones are all history. I don't know who added all these things. So let's move on directly to look at now. Microorganisms can be named based on their what? Origin. Okay, they can be named based on the origin of the microorganism. So we said the Greek philosopher Aristotle was the first scientist who attempted to classify all living organisms into plants and animals. He later regrouped animals into land-dwelling and then water-dwelling and air-dwelling animals. These classifications were thought to be deficient in one way or the other. Subsequent scientists also tried to classify living creatures by means of locomotion, grouping butterflies and birds flying, and so on and so forth. Mr. Emma? Hello? Yeah, I wish I can give you. Okay, you are, all your people are using this material, so you just have to manage with this. I have some material. Some of the things that were added are just repetition. You could see that what I was reading are just repetition of some of the things. So the main thing you have to focus on is that microorganisms can be named first based on their descriptives. Okay, the first thing that can be used to name microorganisms is based on its descriptive. So we can talk about microorganisms, for example, Staphylococcus aureus. Staphylococcus aureus, which is a grape-like cluster of sphere. So you see, when you are talking about, I don't know, those who did a little biology, okay? I think we all did biology, right? Interscience, biology.
Yes, please.
Yes, sir.
So when we are talking about microorganisms, we have the way in which they appear, okay? They have shapes, especially bacteria, they have shapes. So some of those shapes can be used to describe the microorganism. Some of those shapes. So we have the rod-like shape, we have the spherical shape, we have the spiral shape, we have the, what do you call it? Rod-like shape. And all those things are things that we can use to name microorganism. So we have something like coccus. When you hear coccus, it means that the microorganisms is what? Spherical in nature. Is that okay?
Yes, please.
Do you know what a sphere is?
Yes, please.
Yes, sir.
Around.
Looks like an egg.
Okay, so something like that. That is how this kind of microorganism look like. Some look like the rod, some also look like the spiral, and so on and so forth. Then, apart from that, you come to the scientists who discovered that microorganism. Some of the microorganisms are also named based on the scientists who discovered the microorganism. So, for example, we have the Escherichia coli. Escherichia coli. It was discovered by a scientist named Theodore Escherick. So the person who discovered that kind of microorganisms, name was used to name the microorganism. So we have Escherichia coli, which was discovered by Theodore Escherick. Then we have the Ehrlichia, which was discovered by Paul Ehrlich. We have Neisseria, which was discovered by Albert Nissau. We have Listeria, which was discovered by Joseph Lister. We have Pasturella, which was discovered by Louis Pasteur. We have Yersinia, which was discovered by Alexander Yersin. We have Bartonella, which was discovered by Albert Barton. We have Morganella, which was discovered by H.D.R. Morgan. Then we have Edward Celia, which was discovered by P.R. Edward, and so on and so forth. Some microorganisms are also named based on the geographical locations or the geographical places they were discovered. Is that okay? So we have the Legionella longitudinale, and this is discovered at a Long Beach around California, and so on. Then we have, so what you should bear in mind, all that should come to your mind is that when we are talking about the naming of microorganisms, microorganisms can be named by their descriptive, that is their shape, how they look. They can be named based on the scientists that discovered them. They can also be named based on the geographical places they were discovered. And then we can also name them based on organizations. So based on organization, we also have the Legionella, which was discovered by the American Legion. So I hope you are okay with that. For if examination, they should ask you, outline 4 ways or 4 common ways by which microorganisms are named. I hope you can mention them.
Yes, sir.
So we have the descriptives, we have the scientists who discovered them, we have the geographical location where they were discovered, and then we have the organizations that discovered them. Mr. Emmanuel. Hello.
Yes, boss. Yes, boss.
Please let me hit you up with another slide, okay?
Okay.
And Philip came over for good soup.
Some of the things here, I think, are just like excess additions that are not needed. I don't know.
Hello.
We are here.
Oh, okay. I thought I was only the one.
Me too, I can't hear anyone.
We
Yes,
are all
yes,
here.
I
We are
can hear.
waiting.
We are
Oh,
here.
okay.
We are here.
We are all here.
Oh,
We are all there.
Mr. Emma. Hello.
Yes, I've received them.
Okay.
Yes, I've received them.
So please,
Just
you
put
see
it.
the new ones I've sent to you. Hello. Mr. Emmanuel.
Yes, I'm now pushing it to the platform.
Yeah, I want to make a clarification first before.
Okay.
These ones are not for your switch people.
Okay.
Is that okay? These ones are
Okay.
not for your switch people. I feel like the other one is too complicated, so I'm giving you this one. So I'm doing this just to help you people. So don't go and share it. If the coordinator says it, she'll not be happy. I feel like this is in a way simplified than what you people have. That is why I am giving this to you.
Colleagues, over to us.
We hear. Well noted.
That's good news. Thank you so much, sir.
Copper pit, sir.
All right. So I'm using this one to teach now. I mean, the time is almost up. So focus more on the one that I just sent to you, okay?
Okay.
Yeah.
Sir.
But when you are
Okay.
done with this one, the questions that are under the other ones, you can try your hands on them to see. Let your
Okay.
focus
Thank
be
you
here.
very much.
You're
This
welcome.
one is more simplified.
Yeah,
Thank you.
I don't know why. You know, we teach this one during regular, but I've not been teaching this during code. So I think the people who have been teaching added certain things. But this is what I use for teaching. Is that okay?
Thank you. Yes.
Thank
Abigail.
Hello.
Yes.
I
Abigail.
was talking. Yeah, sorry, okay.
Mute your mic.
Okay, so the time is almost up, but let's do something small and then move on. Okay. So we said that the nomenclature of microorganisms. So the science of classifying organisms into hierarchy group is known as the taxa. Taxonomy consists of classifying new organisms or reclassifying existing organisms. I've said this one already, right? Microorganisms are scientifically recognized using a binomial nomenclature, which means two words that refers to genus and then what? The species. So we have said this one too already. Then we came here. So these are the examples of how to classify microorganisms. So based on the scientists who discovered them, based on their descriptive, based on the geographical places they were located, and then the organizations that discovered them. Then we come to the order in which microorganisms are named. So microorganisms are named based on the following order. It has an order based on which they are named. So the first one is that we have the kingdom. Second one, we have the phylum. Third one, we have the class. Fourth one, we have the order. Fifth one, we have the family. We have the genus. We have the species, and then we have the subspecies. Is that okay?
Yes, sir.
Yes, sir.
Okay, so if you as you go, I'll let you read more using the other slide that was given you. When we talk about kingdom, what does it mean? So we have different kingdoms. We have kingdom Animalia, we have the kingdom Plantae, we have the kingdom Fungi, we have the kingdom Protista, we have the kingdom, so the kingdom, we have 5 kingdom first. Now I think there are additions. So you read something small about them, then you come to the phylum. So just read small about them. The time is even up. I don't want to add more. So try to read that. When we meet next week, I'm sure I'll be able to finish this one with the 3. I'll finish this one with the 5 next week when we meet, because this slide is simple, manageable. So I'll finish this one with the 5, and then maybe the following week we'll do the 6. But I will try to get you some questions to try your hands on, and then let's see.
Okay, so thank you very much.
Thank you.
You're welcome.
God bless you.
Amen.
Enjoy
So please,
the rest of your day. Bye.
if you have any questions for me, just ask.
I think the
Saima.
question next week when we meet. We've done great job.
Saima,
Yes.
please, earlier I called you this morning. The number I asked you to send the links to, please forward what Master shared today, the lecture shared today on it for me.
I have something to say on this. Colleagues, in case of a situation or in case of circumstances beyond your control, like Grace, as you are saying, your circumstance is different. So I'll send it to you. Some don't have any circumstances, but they ask me personally to send slides to them each and every day. We have more than 70 to 80 students on this platform. And if everybody is asking me one by one to send the document to them, it means that my data will be depleting. So I beg of you, when I put, if anything, I'll put it on the platform so that all of us will get access to it. If anything, I will still put it on the platform so that you go for it. But if you ask me personally, and then a different person also asks me personally, and I get about 20 people to 30 people asking me personally to send it to them individually, I'll be depleted. So I beg of you, colleagues, some of these informations, they should be on the platform that a lot of people will get access to. So if you want to ask anything, unless in a circumstances that is beyond your control, like I said about Grace's own, she traveled and then yes, she had issues with the phone. That one is a new circumstance, so I can do that. But some don't want to search through their phone for information, and they will be asking for more. They have the information on their phone, but for easy access, they will still ask for more. So I beg of you, if you have any information, search for it on your phone rather than asking again to be sent to you. You'll be having a duplicated document on your phone, and it will even make your capacity to go low. Yes, thank you very much on this. Yes, madam.
Please, on the slide that Sarah just shared to us, the simple one that she just shared.
I would suggest that we don't put it on the centers, the platforms for the centers, because I'm sure some of the
That is
coordinators
it.
are on those platforms. So I
Exactly.
prefer it should be
Exactly.
on
That's why.
the integrated science platform. So don't forward it to anyone. So it's better
That
the
is the
person comes
reason
to the
why.
platform and then check it.
Exactly. We should be very careful, because if we give this thing out,
The
it means
coordinators
that
are on the platform of the
yes, they are on each platform. So the coordinators themselves
Yes.
are. If you can remember, was it last week? We were having one of the calls, and then one of the coordinators just chipped in to. He said that he just came to greet us to find out whether the program is going on.
Yes.
Yes, you remember. Was it last week or 2 weeks ago? So they are on it. So if we are not able to contain this and it goes out, let's be mindful that we will not get anything else again. So let's stay by. We are all adults. Let's stay by it. Don't give it out. This one is a simplified
Okay.
one for you yourself to study on your own.
Good. And okay. And I will sure there's no coordinator here in this the very platform we are in.
No. The only person on this platform is the tutor, the one who just.
Integrated science
Yes.
platform, that one is only the tutor that is on it.
Yes.
But
you know, the one
that's
that
created by ourselves. So
this one was ourselves.
Okay.
The platform was created by ourselves. But the one we are, I'm coming up, the one we are using by the center, that one the coordinators have access to it. Like the one we are using right now, they are recording and they have access to it.
We are being recorded. So we should also mind the way we talk. We are being recorded.
Are you doing something bad? You are not doing anything bad.
No,
you are not doing anything bad.
We don't have to be discussing it
some
on
of
this
these,
platform.
please, some of these recordings, the coordinators, they don't listen to it. It's 3 hours forward, they don't listen to it. They only record and put it there.
They record and put it there, but the last time,
So
one madam was telling us that when they go, they listen and then they edit before they go and put it on the blue, YouTube. So we have to be mindful of what we do.
Please, let's end the discussion right now. We have our own platform that we do discussions on. When we get there, then we continue.
Sure.
So let's end it right now.
Hello.
So very much.
Hello, Brian.
Next week we'll be meeting you next week again, and we'll read ahead.
Hello, Brian.
Yes, madam.
Hello, please, in case you are having any group discussion, please try and include all of us. Let us have the link so that we can also join.
Yes, we normally have one discussion. We have one subject per a week on Wednesdays. Yesterday we had curriculum. But we had food and nutrition. We couldn't have food and nutrition on last week, Tuesday.
But you didn't give us
It was
the link,
shifted to
so
Wednesday.
please
That's why
next time give us the link so that those who are interested can join.
Okay, I put it on the platform, but it was not on the science platform. It was on the curriculum platform, which a lot of people are not on it. So next time I will put it on the science platform.
Yeah.
Yes. So next.
Okay.
So it will be next week. It will be next week Wednesday. We'll be doing foundation.
And if you can also sign the
Please,
okay.
I'm putting. Let's shut this one down. And I'm putting a new one. I'm putting a new one. All of us join for about 30 minutes for a discussion. Do you get me?
Okay.
I'm putting.
Yes.
Please go to the platform right now. I'll close down this one. Let's go to the platform and then join the one that I will put on the platform. We have our own Meet platform that we meet on. So let's meet on that one so that we discuss. So that this one is being recorded so that we leave this one.
Discussion.
I'll put it on the science platform right now. And let us join. Those of us who can join, let's join for a little discussion. Before 11:50, we meet for foundation class. So, sir, we thank you so much, Mr. Israel.
Okay, you're welcome. So I'll work on the questions and
Okay.
then let you have it, okay?
Okay, sir. Thank you. God bless you. Okay.
You're welcome.
Bye-bye.
Bye.
the curriculum and foundation, we have the same lecture. So that's yes. So that is what we use. No, it's on our Zenith page. Yes. Please, are you at Zenith? Zenith, we have a page. Yes. Yes. Okay. You're welcome. So please,